Exercise 1B. In this exercise, we'll add park data and census data containing demographic and socio-economic information to our map. Our goal is to pay attention to patterns in the data and thereby build an intuitive sense of likely and unlikely locations for the park. This intuition should give us confidence that the analysis results we get in Lesson 6 are plausible. We'll go back to our Lesson 1 map document and expand the catalog window. Inside the UGIS directory, we have a file geodatabase called esri.gdb, which contains a variety of source vector data that we'll be using throughout the book. Inside a featured data set called Landmark, we'll locate the feature class Parkland and drag it into the map display. In the table of contents, we can right-click and zoom to the entire layer. This is a collection of lands in the Southern California region designated as parklands. The big areas to the north are actually national forests. ArcMap randomly symbolized the layer, but we'll change it to a nice green color with a darker green outline, which is an intuitively better cartographic choice for parks. Now we can expand the associated attributes with the Identify tool. Here's the Angeles National Forest. In addition to its name, other attributes include its type and its size in acres. We can use the spatial bookmark we created in Lesson 1A now to zoom into the city limits. At this scale, we can start to make out larger parks within the city. With the Identify tool, we can click on some of the larger ones along the blue line. But we're still too far out to make out parks as small as the 1-acre ones like the ones we're trying to locate. Now we can explore the associated attributes, including the crucial size measure with the Identify tool. Let's go to the Dodger Stadium bookmark next and zoom in real close. At this scale, we can finally see parks as small as 1 acre. Here's one that's 2.8 acres, and another that's 6.2 acres. This is more the realistic size range that we're after. We could keep clicking on parks to see their names, but it would be convenient to have them labeled. Right-click the layer name and select Label Features. The default label text is small and hard to read, especially on the smaller parks where it extends onto the imagery. So we'll open the Layer Properties and click the Labels tab to make some adjustments. We'll begin by increasing the size to 9 points. Instead of black, we'll switch to a light green, which will show up better. But to be legible against the busy background, it will need an outline, or what we call a halo. To create the halo, we'll edit the text symbol. Under the Mask tab, we choose the Halo option. As seen in the preview pane, the default halo is too thick, so we'll change it to 1 point. It will also look better set with a darker fill color of moss green instead of the white. Once we click OK to accept all the settings and close the various dialog boxes, our labels show up nicely against both the features and the background. If we zoom back out to the City of Los Angeles bookmark, the labels overwhelm the display. They're not useful at this scale, so we'll set a scale range to suppress them. In the Scale Range dialog, we tell ArcMap to not show the labels when we are zoomed out beyond a minimum scale of 1 to 40,000. When we save these settings and dismiss the layer properties, the labels are now hidden. But when we go back to the Dodger Stadium bookmark, the labels reappear because at 1 to 24,000, the map scale is now below the 40,000 threshold. We can emphasize these labels a little more by dimming the base map. On the Effects toolbar, set the target layer as Imagery Base Map and the transparency slider at 10%. Now let's go back to the catalog window and add a layer of census tracts. Zooming to the entire layer, we can see that it covers Los Angeles County in its entirety, including 2 offshore islands. Now let's open the attribute table and see what kind of demographics are included. In addition to some identification codes, the table includes many population attributes and breakdowns of ethnicity, sex, age, household status, and housing. Some of the fields are easy to interpret, others less so. We're going to look first at the population density value, a field called pop07_SQ mile. This attribute stores values for population per square mile for the year 2007. Right-click the field and choose Statistics. We get a summary which includes a frequency distribution chart, or a histogram, that shows us that most of the values are between 0 and 25,000, with the remaining values spread out over a long tail. Symbolizing a layer by an attribute is called thematic mapping. Let's create a thematic map of population density on the tracks layer. We'll set this up in the Layer Properties under the Symbology tab. In the Quantities section, we accept the default graduated color setting and set the value field to the population density attribute for 2007. The default natural breaks classification has divided the features into 5 classes. The map looks okay, but we can simplify the classification scheme to better understand what we're looking at. Back in the Symbology tab, we'll reduce the number of classes to 3. Now, click the Classify button. By choosing different methods, we're changing the algorithm used to set the class breaks, and the histogram below updates to show us where the breaks will occur. We'll try the quantile method, which will place an equal number of records in each class. Now we can click in the Break Values section and manually adjust the values to round numbers. We'll make some changes to the symbology as well. If you click the Color Ramp drop-down, you get a large set of color ramps. By right-clicking the drop-down, we have the option of viewing the color ramps in graphic view or by name. We'll select the one called Red, Light to Dark. This is now an intuitive color scheme. The darker the symbol, the higher the population density. The outlines around the symbols are a distraction, so we can remove them from all the features by editing the properties and changing the outline color to no color. Another thing we can do in this panel is to change the labels that appear in the table of contents from the actual numeric values to the simple words low, medium, and high. Again, the goal is to create understanding. If we click Apply, we get an immediately clear picture of where the greatest population densities exist in the city. Unfortunately, our thematic map is totally obscuring everything below it in the table of contents. So now if we click the Display tab, we can change the layer's transparency to 50%. Back at Dodger Stadium, we see both the population density and the underlying geography, and a clear picture is starting to emerge. With the Measure tool, let's check out the distance from the river to a few parks that are quite close to the center line. First, we'll change our measurement units to miles. Here's a park called Cypress Park. It's about 1/10 of a mile. This playground, called Downey Playground, is practically right on top of the river. Just to the north of the stadium, we see Elleria Canyon Park at just a little over 1 mile away. And then over here west of the river, we find Elysian Valley Rec Center Park, very close at just 0.17 miles. After we're done measuring, we'll go ahead and close the Measure tool. Then we'll use our bookmark again to zoom back out to the city limits. Recall that one requirement for the new park is that it must be located in a relatively low-income area. So now we'll go ahead and add another layer of census geography data, this time at the more detailed block group level. When we open the attribute table, we see the same kinds of demographics that we had at the tract level. The main difference being that this layer divides the same county into about 3 times as many polygons, so it's more detailed or granular. This field contains attributes for median household income in the current layer. Running statistics gives us a distribution bar chart like the one we already saw for the population density. Let's close the attribute table and open the layer properties. If we made another graduated color map from this layer, it would be difficult to evaluate the 2 layers at once, so we'll use an alternate symbol style that will work. Click the Symbology tab, and this time under Quantities, choose Graduated Symbols. In the Fields Value drop-down, select Medium Household Income _ CY for current year. Reduce the number of breaks to 3, accept the default classification, and then manually set the first two break values to 50,000 and 100,000. Click the Template button and change the symbol to a circle number 2. Now set the color to tourmaline green to give it a nice contrast. Since we don't want the actual polygon to draw at all, we'll turn off the background symbology by setting both the fill and outline to no color. Next, we'll increase the minimum symbol size to 8 and the maximum to 24. Like we did with the population density labels, we'll also make them read low, medium, and high by clicking in the label field and typing in the words. Clicking Apply and moving the dialog, we can see that we run into the same problem we had with our labels, overcrowding at a wide scale. So we'll go to the General tab now and set up another scale dependency. This time we'll set it to not show beyond 1 to 100,000. Before closing the layer properties, apply a 20% transparency to the layer. And now click OK. Next, zoom into the Dodger Stadium bookmark. Here we can start to get a general sense of income and population density in relation to park locations. We're only looking at 2 variables so far, so this is a partial view of the more complex problem we'll study more rigorously as we move along, but it does provide us with a good first look. Areas with high population density in dark red and low income with small circles will be good areas to consider. From the Toolbars menu, we'll now add the Draw toolbar so that we can mark some of our preliminary guesses right onto the map. Later, we'll compare these to our actual analytic results. First, we set the default symbol properties on the Drawing toolbar. We want to draw an empty ellipse, so we'll set the fill to none and the line width to 3 points, the color black. Now when we go back to the Drawing toolbar, we can choose the ellipse and begin drawing shapes right onto the map. Here's an area right in the middle of the display that looks promising. A dark red polygon straddling the river with a small green circle. These drawing objects are different than geographic features in our database. As such, they can be manipulated, stretched out, resized, or repositioned any way we want. We'll make this one big enough to roughly encompass the entire dark red area. Once we have the object sized and positioned the way we want it, we can pan up and down the river in search of other suitable areas. Eventually, we'll end up with several. We'll keep drawing guesses until we've included all the areas that we think might be good potential candidates. Save the map. Now we'll export the map as an image file that we'll be able to open later and make our comparison. We'll navigate into the UGIS folder under Parksite, the Maps and More directory. Change the file type to a TIFF. Call it Lesson 1 Predictions. Click the Format tab and check on Write GeoTIFF tags and click Save. Before exiting, turn off the Draw toolbar. And also the Effects toolbar. Then we'll exit the application.